Welcome to mathematics. In this video we will check a number for divisibility by several smaller numbers without actually dividing it. When we say divisible, we actually mean that a number is said to be divisible by another number if it can be split equally, leaving no leftovers. Let me give an example here. For example, there are 3 kids, A, B and C, and there are 15 chocolates that need to be shared. So I'll start splitting them, okay? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So all of them got equally and no remainders left. So that means 15 when divided amongst 3 is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Each child is getting 5. When it's equally split between categories or people or whatsoever, when there's basically no remainders left, that's when we say it is divisible. So 15 is divisible by 3 and the answer is 5. Now I'll take a bigger number, say for example 32,760. Now here I'll apply the checks, and on the side you divide the whole thing and see if the check works well. So for the first one I'll do it for you. Let's see, this is check for 2, check for 2, okay? Now check for 2 is that last digit must be 0 or even. Now here the last digit is a 0, so as per the check this should be divisible. I'll quickly divide this with you. 32,760 to 1 times 2 to 6 times 12 to 3 times 6 to 8 times 16 to 0 times 0. So 32,760 divided by 2 equals 16,380. The check worked well here. It is divisible. The next check for 3. Here I'll just do the check and you on the side will actually divide and see if the check works. Check for 3. Check for 3 is if the sum of digits is divisible by 3, then the entire number is divisible by 3. So sum of digits means 3 plus 2 plus 7 plus 6 plus 0, which is equal to 18. 3 how many times is 18? 3 6 times is 18. So 18 is divisible by 3, hence the entire number will be divisible by 3. Quickly divide it and check here. Meanwhile, I'll move on to the next one. Check for 4. Check for 4 says if the last 2 digits of the number, now what's the number? It's 32760. 32760. If the last 2 digits are divisible by 4, then the entire number is divisible. I'll just quickly divide 60 by 4. 4 1 times 4. 4 5 times 20. The last 2 digits are divisible by 4, hence the entire number 32,760 is divisible by 4. You quickly divide it and please tally. Moving on to the next check, that's check for 5. Check for 5 says that the last digit should be 0 or 5. So the last digit is 0 here, hence it is divisible. Moving on ahead, check for 6. Check for 6 says Check for 6 is the number should be divisible by 2 and divisible by 3. Now this number is divisible by 2, that's right. It is divisible by 3, that's right. Hence the number is divisible by 6. Now this check, it's a little shady here. This check is not 100% applicable every time. There may be some exceptions, but usually the check works well. Moving on to the next one, check for 8. Check for 8 is similar to check for 4. Check for 8 says, if the last 3 digits are divisible by 8, then the entire number is divisible by 8. Let's quickly check that. 760 divided by 8. 8 9 times is 72. 8 5 times is 40. The number is 760 is divisible by 8, hence the entire number 32,760 is divisible by 8. Moving on, check for 10. Check for 10 says if the last digit is 0, then the number is divisible by 10. Moving on to the last one, and this is a little complicated, so please be very, very attentive here. The last check is check for 11. Check for 11. Now check for 11, I'll quickly read out the check first and then I'll explain. It says a number is divisible by 11 if the sum of numbers at the even places and the sum of numbers at the odd places. Let me pause here. I'll just do the sums first. So the number is 32,760. I've purposely written it spaced out. This is the first place, second place, third place, fourth, and fifth, right? So we're talking about sum of digits at the odd places. This is odd place, this is an odd place, and this is an odd place. So sum of digits at the odd places, 3 plus 7 plus 0, 3 plus 7 plus 0, which is a 10. Sum of digits at even places, 6 plus 2 is an 8. I'll complete the rule now. If the difference of the numbers obtained by the sum of digits at the odd places and even places is 0 or a multiple of 11, then the number is divisible. Now difference of these sums is 10 minus 8. What is 10 minus 8? 10 minus 8 is a 2. So difference of both sums, this was sum of odd places, odd placed digits, and this was sum of even placed digits. Okay, so both the sums, difference of both these sums should be 0 or multiple of 11. Now this is a 2, hence 32,760 is not divisible by 11. However, we will quickly do another number. 104,522. Let's quickly check here. This. Sum of these three. 2 plus 5 is 7. One number is 7. This, and this. 2 plus 4 is 6. 6 plus 1 is 7. The difference of both the numbers is a 0. Hence, this entire number should be divisible by 11. Let's quickly use short division. 104,522 to check it. 11 9 times is 99, 100, 101, 102, 103, 104. So 5 comes here. 111, 11 5 times is 55. 11 9 times is 99. 11 5 times is 55. A 0 here, and 11 2 times is 22. Hence verified this number is divisible by 11. I hope this was helpful. Thanks for watching this video. Please subscribe to my channel, like it, comment on it with your feedback, and share it with others. Thank you.